General fiber knowledge. In this presentation I would like to address the following subjects: general fiber, fiber types, attenuation, optical connectors and small must-knowns. Glass fiber can transport an unlimited amount of data. For this you can use different color techniques like CWDM or DWDM and different speeds, 1 gig, 10 gig, 40 gig and 100 gig, or a combination of both. In general you got two different types of glass fiber. You get the multimode and the single mode. The multimode are orange cables, orange or aqua bluish cables. On the cable itself you can see there's written 62.5 divided by 125 or 50 divided by 125 or OM1, OM2, OM3. Those are multimode standards. You can use these cables with SR or SX optics. The more modern cable is the single mode cable. Those are the yellow cables. The single mode is a really thin core. It's got 9 microns thick, so 9 divided by 125 is written on the cable. And all the dark fiber in the world is made of single mode cable. One type of single mode cable is the standard G652.C or .D. The loss of light is depending on nanometers, which means different color has different loss. In the DWDM spectrum, which is around 1550, you got a lower loss than on the lower band of the CWDM. The CWDM is from 1270 to 1610, and for example 1310 it has a loss of 0.4 dB per kilometer, and 1550 has 0.25 dB loss per kilometer. If you want to calculate what your loss of the line is, you can do that with different techniques. You can use an OTDR. With an OTDR you can see exactly what the loss of line is, and you can also see the patches on your dark fiber. Another way of doing this is putting optics with DOM features on both sides and just calculate it. In Cisco you can use this DOM feature. You can see the power, the transmitting side. So this is for example 0.91 it's sending out, and it's receiving with -12.29, and the other is around the same. A third way is to calculate, and this gives you a rough estimate. If you got a line of 44 kilometers for example, you multiply that with 0.27 dB, which is on the safe side, you got around 11 dB. On every optical line ends with a connector. You got around 20 different connector types, but the most popular ones are the SC and the LC. SC is used for XAMPX X2s, and LC are used for XFPs, SFP pluses. The last slide are just some small must-knowns about fibers. With 10 gig and above 80 kilometer you got something called chromatic dispersion. And that's only with 10 gig and above 80 kilometers. So if you got 1 gig, 2 gig, you don't have to take this into account. And that's the fact when the waves are overlapping each other. We got a different presentation that I will explain you how you can compensate the chromatic dispersion. Another important thing to know is that you got older fiber type, that's the G652A and B, which have something called the water peak. The water peak is a phenomenon where the attenuation is so high that no light can pass through. Waves 1370, 1390 and 1410 are affected by this, but 95% of the fiber in the world nowadays is C and D, which don't have the water peak. It's important to work clean. This is a picture of a lens surface where you can see a lot of dust. If you have an optic which is 80 kilometers, you really have to work clean. If there's a lot of dust, you won't reach the 80 kilometers. We can supply you cleaning pens and cleaning pads to work clean. Another important thing what you can see in a data center is APC connectors. Those are the green connector types, and they got a little angle on it. 5% of in the data center you will see that 95% is just the standard UPC connector. But you have to take that into account. Green connectors have to be connected to green connectors.